and then we can get on our way with some Arduino-y things. Excellent. Just so I have like an indication, I'll on the Discord put up a little poll asking how many people made it to the last session. I think I've seen quite a few at the last one, and this is like if you've watched the video as well, if you weren't here for it. So we're at Warsaw the last session. And that's just so I can get an idea of where people are at with things, and how many like specific questions to ask about the previous one. And I'll also start sharing my screen. Share a screen. That's the one. All right, and we'll start with what we're eventually getting to. All right, cool. I think all is well. We have a recording started. As many people that are going to show up seem to be here, so we'll get on with it then. Okay, so for those of you who did make the last session, in that one we learned a little bit about the basics of Arduino and working with microcontrollers. So combining our electronics knowledge that we've been working on with some programming as well in a new language. So today's goal is going to be to basically re-implement this whole project here. And this project uses this keypad, which we're going to have to figure out how this exactly works, because if you notice, of course, this is a 4x4 grid, so there are 16 buttons here, but only 8 wires. So we're going to figure out how grid circuits like that work, as well as how you can control a servo motor. So this little motor is a motor that goes to a certain angle that you tell it to. So if we start our simulation, it, I think by default goes to halfway, which is 90 degrees. So you see it's at 90 degrees. If I type 0, and then this is my little enter key, I've arbitrarily assigned it, 0, and then enter, it'll go and it'll turn to the 0 degree, 90 will get us back to the middle, if I can press it correctly, there we are, and then 180 would go all the way the other way. So that's what we're going to be building towards today, is implementing this, because it teaches us lots of good concepts. But I think we'll start with something a bit revision, and then we'll add on the new thing, and that'll build us towards this. But we'll get there gradually. So, on that note, I will go back to here, and we'll create a new circuit. Sure, that sounds like a good idea. All right. How many of you remember how we made our button pressing circuit last session? We're going to be improving upon that. So I suppose I'll ask a more specific question. What components am I going to need to use to build a circuit that lets me detect with an Arduino a button press? So I'll press a button and I want the Arduino to print something out, say over the serial console. What physical components should I drag out here? Just throw out some ideas in whichever chat you please. I think that's a good idea. So if we're going to want to pick these things up with an Arduino, we're going to need an Arduino. Yep, and then also a button. In the real world, it might be slightly difficult to connect this button directly to an Arduino. Is there something that could help us? Yes, exactly. Look at that. A breadboard. I think that's an excellent idea. Wonderful. So I'll go ahead and drag out my breadboard. Does anybody remember where we want to put this button on the breadboard? There's a particular place it usually ends up being. But it's all right. Yes, yeah, over the center. Yes, I would agree. So that way, all 4 of these pins are connected to a separate thing, which is exactly what we want. Wonderful. I totally agree. So, in that case then, what we want to do is connect up the Arduino now to this to read it. Before we connect up, say, the button in particular, is there anything else useful it would be, or are there other useful connections that we could make between the Arduino and the breadboard that aren't necessarily button specific just yet? Hey, I agree, that's an excellent idea, Philip. Some power connections. So I'll arbitrarily rotate this that way. Then we can go ahead and take our 5-volt power here, which is our positive line, and we'll go ahead and connect that here to this positive rail. I'll change the color since I'll try and do that today, so it's a bit less green everywhere. Then we can take our ground and do a very similar thing with it. So we can go here, whoop, and over there. Lovely, and that can be something like black. Traditional colors for ground and power. Wonderful. Okay, so recall that when we press down this button, what it's essentially doing is connecting these terminals to these other ones here. So when you press that, it connects this lane to this lane, effectively. If we're reading this with an Arduino, we probably want to have power on at least one side of this button. Doesn't matter which. In my case, I think I'll put this power line here on this side, because it's nice and convenient. And then what I can do is connect something to this side of the button. And these two are the same row, effectively. So I'll take a line out of here. Does anyone know which set of pins on this Arduino are a valid place to connect it to? Can I connect it down to these ones or up to these ones? Is there a specific set of pins that I should be connecting my button to? Yes, I would agree, the digital ones. Yeah, so because the button is either, or at least this type of button, is either pressed or not pressed, that's a digital thing, so it's just a yes or no, it's binary. So that's what the digital means. It can either be a 1 or a 0, a low or a high, so it's either pressed or not pressed. If you had something that could be in the middle, like last week when we played with our potentiometer, which was a little dial you could turn, that would be connected to the analog. But here we want to connect it probably to one of the digital pins. And in this case, just about any of them are fine. 1 and 2, or sorry, yeah, 0 and 1 have some specific uses, and they can sometimes, or you can sometimes interfere with things if you make connections to those when you're not meaning to. So I'll probably just connect it to the first non-special pin, which is 2, up there. And I don't know, yellow seems like a signal color. Fantastic. I think that's about all we'll need for our circuit itself. We could add a resistor in here as well, but we also learned last week that there's a way to do that in software. So I think we can take a look at that as well. So first of all, we'll go and we'll open up our code. Right, yeah, switch to real coding. Okay, fantastic. Then from here, we'll need to do a couple things. We'll start with the setup, and I'll keep asking you guys some questions, because this is still the review bit. We'll get onto the new bit once we've got this implemented. How do we set up for our button? And remember, we want to do 2 different things eventually. We want to print to the serial console, and we want to read a digital pin. Any suggestions for what goes in the setup? Assign pin 2 to be an output. Okay, so I agree that we should assign pin 2 to be something, but should we assign it to be an output in this case? I suppose we could, but we might be looking to do something a bit different. But I agree, we'll be setting some sort of pin mode, and it'll be pin 2. I think in this case, instead of setting it to be an output, we probably want it to be an input, because we're trying to detect if this button has been pressed. And that is our goal here directly. Oh, additionally, I've realized that I've not, fully connected the button. Yeah, okay, so that's probably part of the confusion. My bad. When I said it was done being connected earlier, I lied to you. As Philip has probably noticed, this side isn't actually connected to ground anywhere, which is why it would make sense, I guess, for maybe this to be an output, so you could set that to ground so the power flows that way. But what we really want to do is connect this to ground through a resistor here, yes. So that's my bad. So we can go ahead instead, and I'll put a resistor here, and then just connect this line to that one. That's a ground connection. So all that's saying is that it lets the power flow through when you press the button here, and we'll be able to detect on our digital pin 2 whether or not power is flowing through or if it's not. The reason to think about that conceptually is when this button is unpressed, it's as if this whole side of the circuit doesn't exist. So it just looks like pin 2, which is connected to a resistor through ground. So since it's only connected to ground, it's just going to see that 0 volts, and that's how you get your value of 2. Or you'll get your low value when it's not pressed, because it'll be 0 voltage on pin 2. But when you go ahead and press the button, you're going to be connecting this red side as well. So in this case, you have 5 volts that come up here, and this 5 volts is connected to pin 2, and then the 5 volts is also connected to the resistor and then the ground. So here, the power is lost across the resistor, so this resistor will drop those 5 volts, but we're reading before the resistor, so we'll read 5 volts up here. So we get a high signal when we've pressed that button. Does that make sense? I'm sorry for originally connecting that button wrongly. Does anyone have any questions about that? I'll make a poll as well. All right, I'll ask if everything is making sense so far, and then we'll power onwards. And the polls are on the Discord channel if you're having trouble hunting those down. I don't think I have access to free polls on Google yet. I'll have to see if I can figure that out. I think if you register as a teacher or something, you have ways to do polls. But okay, so we've got 3 people. Oh, up to 6 people. Wow, look at that. Very fast. Or I guess 5 people who said yes, it's making sense, which is excellent. So if you have any questions, feel free to type those. But if not, we'll continue onwards now that I fixed my broken circuit. As Philip originally pointed out, we should be setting the mode of pin 2. And now that my circuit is connected correctly, I can safely say we want to set that as an input pin. That will let us read voltages from this pin. Excellent. So that's 1/2 of our setup done. What other thing do we need to do in our setup if we need to, or if we want to write out to the serial console, which is this thing down here, the serial monitor? If we want to write out to that, what other thing needs to go in the setup? Does anyone remember? And if not, that's all right too. This is one of the sneakier ones. Yes, yeah, the serial begin thing. I definitely agree with you. Fantastic. Yes, so in our case, the serial.begin, and this capital here matters as well. It only picks up this serial object, which is what you're calling this method on. So it's like when we were in Python, how it has this associated data. So when you're running the begin, it's running it on whatever's on the left side of the dot, which is serial here. Ah, yes, duh, of course. Very, very, very good point. Totally forgot that I have to like present these things. All right, is that a little bit better there? Very sorry. Okay, excellent. Cool. Off to a bit of a bumpy start, but that's all right. I've got you all looking out for me. Wonderful. So, yes. So as I was saying when nobody could see it, this serial begin bit, it matters that the serial here is capital, because that indicates that it's the special serial object. If it were just lowercase, it would complain about not knowing what that variable is, because we haven't created a lowercase serial variable. So it's case sensitive, so it's just something to look out for. And then, inside of the begin, we just give it the baud rate, which is how many bytes to send a second, so it's like the communication speed. A very standard one, like we talked about last week, and we don't need anything faster. It's just 9,600. So that'll send 9,600 bytes a second. Or bits, actually, maybe. Stellar. All right, I think that is all of our setup function. So now, if we wanted to read the state of the button press, how would we do that? Does anyone know how to read a digital pen? Or remember how to? I wish Google told me if people were typing. That'd always be good to see. All right, so that's all right if we've forgotten because it's one of the longer ones. Hey, yes, yeah. So Philip swooping in there at the last minute. I would agree, digital read is the one to use. So with digital read, we can type first the function name, and then it takes a couple of things. It needs to know what pin to read, which is, in this case, pin 2. And it also, well, actually, just kidding. It's a read, so that's all it takes. And what it will do is return either high or low, depending on if this button is pressed or unpressed. So what we can do is store that value. So we can say something like pressed equals, and remember, since this is in Arduino's C++ language, you need to give it a type here. So high and low are really just numbers, so int works fine. So you can get away with int. And then, so that's that one line. And then if we want to print out to the screen whatever the value is, whether it's a high or a low, or we'll do something a bit different. If we wanted to if we wanted to print a message when it was pressed and do nothing when it was unpressed, what bits of code are we going to need to do that? So if I'm not pressing the button, this will stay blank. If I'm pressing the button, it'll repetitively print a line over and over again. Yes, so I definitely think we should use an if-else in there. So we can do if the button is pressed, and you need brackets around these in this language. So if the button is pressed, we want to do something. And what thing do we want to do if it's pressed? If we want to print something to the screen, how do we do that? Or I guess print something over the serial monitor, for that matter, which gives it a bit of a hint, I suppose. Yes, excellent. I would totally agree with that. Serial.println. So serial.print, and then the ln stands for a line. So that puts a new line at the end of it. And we just put whatever we want to print there. So we'll print, I don't know, pressed really excitedly, and print that. And then the last thing we might want to do, does anyone see any issue with this code as it's currently written? And what other thing might we want to add to it? And this one's a bit of a more subtle one. All right. So, aha, yes, look at that. Phil Boy swoops right in the last minute, doesn't he? Fantastic. Yes, I would agree. You would like a delay. The reason for that is because without a delay, this loop just runs as fast as like the chip will let it run. Which can kind of overwork the chip a little bit. What it does is it creates a bit of an inconsistent timing occasionally. In terms of the simulator, what it does is lag our simulator a bunch, I'm pretty sure. So if I go ahead and run this, it seems okay, actually. So it's better than last time I tried it. But the time maybe is moving slightly slower than it should be. Regardless, to spare my computer and also because it doesn't need to run crazy fast, this will also slow down the amount of printing it does. We can add in a delay, make that a short delay of just like 10 milliseconds, so it's pretty quick, regardless. All right, excellent. I think that should be our completed program. So we can go ahead and run it. Yeah, I think that's running a bit faster this time. Not that I really have any perception of time, but you know, I think it's a bit, that's normal seconds now. Excellent. Here's our serial monitor. It's empty because the button is unpressed, and if I press the button, we get a bunch of pressed lines. In fact, we get a bunch of pressed lines because every 10 milliseconds it'll print a new line of pressed. So that is where today's little extension to this system comes in. What we want to do, because like with our keypad, for example, we want to know when somebody's pressed a button on it, but we don't want to have that number repeated, you know, however many times it loops. So no matter how long the user holds down a button on the keypad, once they let go, it should only count as one button press, not a whole bunch of them, is the idea. So to do that, we're going to need to set up a couple of new things. that we haven't done. Well, so language-wise, it's all stuff I think that we've seen before, but the idea here is a bit new. So I think the most popular way to address this sort of problem is you can keep track of if the button was pressed last time you went through the loop, and if the button was pressed last time you went through the loop, then just don't bother printing pressed a second time because you've already printed it, if that makes sense. And then once you let go of it, then it will remember. It can say, aha, last time I went through this loop, it was let go of, but now it's pressed again, and it detects that as the second press. So I realize that sounds a bit abstract at the moment, so I'll show it in code. So I have to stop the simulation first, of course. Clear that, duck that away. So what we can do is create a new variable. We can call it a bool, which is a true or a false value. It's just a nice, sensible type to work with. It makes it very clear that there's only going to be ones and zeros. So this is something that's true or false, and it was, we'll say, we'll call it was just pressed. Or maybe just, yeah, that'll do. So we'll say that. And we'll set it initially equal to false. So not initially pressed. Now what we can do, down, or you know what we'll do? We'll set that actual value in the setup because I think that'll behave a bit better. So we'll go ahead here. We can say was just pressed. So then when we set up, we'll assume that it's not been pressed when you turn the thing on. So that'll be false, just like that. And this will keep track of if it was pressed last time it went through this loop. So the idea then is we only want to print this if it was not just pressed. So what we can do, and I think you might have seen this last time around, but in Python you can chain multiple conditions together by saying like and. So you would say and not was just pressed would be how you'd write that in Python. But since we're working in C++, the and is actually two ampersands like that, and the not is an exclamation point, just to keep things confusing, I guess. But that's all right. This was around before Python was, and I guess it's a bit more concise as well. So now we're only printing if the button was pressed this time, and it was not just pressed the last time. But you may be noticing, we're not setting this anywhere in the loop. So how do we know if it was just pressed? Well, if we printed this once, then we know that it's been pressed, obviously. So we can say then here, and let me think actually what the best way to do this would be, because I think there's a couple ways we could go about it. We can do, actually no, yeah, so that's fine. We can put it, I think, outside the loop. So outside the loop, we can say that whatever the value of was just pressed is the value of this loop at the end, or the value of pressed after we've already run this. So what this means is that we loop through the loop once, we read, is the button pressed or not? If it is pressed and it was not just pressed, then it's going to print that it was pressed. Then what happens after that is this gets set, the last value gets set up for whatever the current value is. So maybe it would be better if I rename that to, yeah, that's a bit clearer, just for the sake of clarity. So last state, doop. And we can also change that to be high and low, where high means that it's pressed. And not last state. Wonderful. State. All right. And then we can do that. And we can get just, we'll name that to current state to keep it similar. Right, okay. So I feel like that might be some clearer naming. So in this case, what we do is when we first start our loop, we get the current state of the button. So this tells us if it's pressed or not pressed. If it's currently pressed and last time it was not pressed, then we'll print that it was. So that'll be our first time. And then what it'll do is set the previous state to this current state, and then it will loop again. So in this case, since we're assuming that this was 1 or high, so it was pressed, we've printed pressed, then we set last state to equal high, which is what that'll be. Then you come around the loop the second time, and when you come around the second time, you read high again. So then you come into here and you get high, so that's true. But then you see that it was also true last time. So because of the not, that turns into a false. So you end up with a true and false, which is false, so it doesn't print it a second time. So I think if I show this to you, and I'll ask questions, because I feel like I've kind of botched the explanation of this one. But here you see I'm pressing and holding, and each time I press and hold, like now, it only prints 1 time. So I can hold down for as long as I want, and then let up whenever, and it only prints 1 output at a time, instead of spamming our screen. Now I realize, especially because I renamed things a couple of times through there, that I may have lost some people. So I'll ask, are there any questions about how this system works, where you can detect only the first button press, or the first time through the loop? I'll make a poll for that. Make sense? So I'll get a poll from people, and then also if you have any specific questions, feel free to ask them. Well, it's reassuring to see that a number of you understand what I was talking about, because there was a bit of waffle there. That's good. All right, fantastic. Okay, well, that was better than I expected, so that's positive. So I'll assume there aren't any questions. If there are, definitely type them, and I'll get to responding to them. But aside, if there aren't, then I think we've done a good job with our button, and we can move on to our next little piece that we'll need. Excellent. Cool. Yes, so feel free to ask questions as they come up if you think of them later. So I think we'll be done with this button circuit, and the next bit of our grand scheme that we need to get together is our servo itself. So we have this new servo motor thing, which I showed you, which can go to some angle between 0 and 180 degrees, but we've not actually looked at how to use that yet. So I think that should be our next mission. So we'll jump back to Tinkercad, it'll load up, it'll be very large, I'll create a new circuit. Okie dokie. So I think for this one we can probably get away without a breadboard even, because we only have 2 components, and we can connect them directly, at least in this world. All right, and we want to look for a servo. There's a couple of options here. I'll pick the first one. I think they're basically identical in this particular case. There are some more diverse servos in the world, though. Ones that go more than just like 180 degrees exist. But for the time being, we can just put this servo here. Helpfully, this also tells us what all these pins are. So this one's a ground pin. So I'll connect that one over to ground very beautifully, as I'm sure you can see. And then red, that's power, so I'll connect that up to 5 volts. These are 5-volt powered. And then finally, you have this last one, which is a signal wire. And that's something we've probably not seen before. Well, unless you've worked with servos. But for servo motors, oh yeah, did I tell you all about, yes, yeah, remember last session when we faded an LED on and off? We used PWM. So that's where you basically just turn it on and off really fast over and over again, but you keep it on for different amounts of time. And so the more in this like cycle of on and off, the more of that time that you leave it on, the brighter it is, and the more that you leave it off, the dimmer it is. But you're blinking it so fast it just looks like a solid thing. Servos internally actually work in a kind of similar way, depending on how fast you're doing that blinking. Or more accurately, I suppose, the duty cycle, which is how much of the time it's on in the PWM signal, that determines the position of this servo. So on the Arduino, we can connect it to a bunch of different places as long as it's a PWM pin. So we can connect it to any of these ones with these squiggly lines, because that's what our label says. So the PWM ones have these squiggles, so we connect our servo to pin 3, 5, 6, 9, 10, 11. And that looks like it, yeah. So I'll pick 9 arbitrarily. We'll connect that one up. We'll make it yellow for the sake of signal wire. All right, excellent. So now, the new bit that this will introduce to us, well, it'll introduce a couple of new things. But the first of them will be importing libraries. So this is code that somebody else has written for us. So you'll remember in Python, or perhaps you'll remember, if not, that's also okay, that there is an import, and then you would give the library name there. In C++, that's a little bit different. You start with a hash sign, and then you do include, and then in some angly brackets, you give the name of the thing you want to include. And here we're including servo and .h. The .h means that it's a header file. If you know C or C++, that might make more sense to you, but it's not terribly important for us. Most of your libraries will have this .h at the end of them when you're working with an Arduino. Excellent. So this includes a whole bunch of code for dealing with servos that somebody else wrote for us. And in fact, it's some code that's included by default with Arduino. So this should be available everywhere you're programming with an Arduino. Then what we can do is use one of the new types that was given to us by this library called servo. That's actually a class, if anyone is familiar with them. We didn't quite get to them in Python, but they also exist in Python. You can think of them as like bundles of data and also functions. So serial that we saw earlier when we had the big serial, that's also a class. But in this case, we're creating a servo. We'll name it, I don't know, my servo. Something very creative like that. Excellent. And what this does is creates a servo object that we can use later. So there's a two-step process to using one of these things. The first step is in your setup, just once, you want to connect this servo to a particular pin. You need to tell it which pin its PWM signal is coming out of. So in our case, you do that by saying my servo. So this is your servo, and you want to do an attach to it. So you do .attach, and you're attaching this servo to a certain pin number. And in this particular case, we're connecting it to pin 9. So we'd write that. And that would be our setup code. And in fact, in this case, I believe that is the entirety of our setup, because we don't have anything too terribly complex going on here just yet. Wonderful. That's all the blink code, so we don't need that anymore. And then what we can do in here is tell our servo to go to a particular position. So just like with attach, where we had the name of our variable, then the dot, and then the function, and then the argument. So here's the servo we're attaching, and you can tell we're attaching because you have the dot attach. Whoops. And we're attaching to pin 9. So here, we're going to take still the same servo. So we start with my servo. Then you give it write. That's how you give it a position. So you want to write some data to it that tells it to go to a position. And the data that we're writing is the angle. And in this case, we'll say, let's make it 0 degrees, because I think it starts at 90. So 0 degrees is what we will tell it to go to. Excellent. Yeah, and then just so we can see something happen, I think what I'll also do is add a delay of 1 second, and then we'll have my servo, and we're going to go back to the other direction. So we'll write the maximum value, which is 180 degrees. So there we are. Excellent. So what this should do is first include this servo library. With that library, it's going to create a new variable called myServo. We're going to attach our servo to pin 9, which was just what we've done here. And then in a loop, we're going to tell it to go to position 0, which is all the way one way. We're going to wait 1 second. Then we're going to tell it to go all the way the other way. And so if we run that code, hopefully we'll see something. Just kidding. Forgot a semicolon. Remember your semicolons, kids. All right, excellent. And it is not moving, which is very exciting. What is the conundrum here? A very good question. And I'm not entirely sure. So let's see. We'll try and debug it. We'll start with just setting... Well, we'll comment out all of this. So we'll just see what it'll do without any intervention. Oh, I have to stop the simulation, of course. So it did move a little bit there, but it certainly didn't do what we expected it to. So we'll go ahead and run that. This should go to the halfway position. Yeah, there we are. So it goes to the halfway position. Then maybe we need a bit of a longer delay, because it does take time to move these servos. So we'll give it a delay up here. Ah, yes, okay, that might make some sense. So that's another second. And we can start. There we are. Okay, that's more what was expected. Okay, so I think the issue we were running into before, maybe, was that we were just going all the way one way and not necessarily the other because there was no delay before setting it back to 0. So it's important to remember that these loops are obviously circular. So even though I had this, delay here in the middle, what was happening is it would go to position 0, it would wait some time for it to get to position 0. So that's the one that it actually ended up at. But then what happened is when it told it to go to angle 180, there's no delay after here, so it just immediately went back to the beginning of the loop and immediately set it back to 0, which is why, of course, we stayed stuck at 0, and that is my fault. So here with 2 delays, we can see it wash back and forth a little bit. So at the moment, when we set these positions, it's moving at its maximum speed that the servo is capable of. Different servos can move at different speeds. So I think our next thing we'll do is introduce a new type of loop that you haven't seen yet, and we'll use that to gradually rotate the servo instead of quickly rotate the servo. Before I get on to that, I'll check how people are feeling about this servo in general and if they're understanding everything here. I think this is not as dreadful as the last one, but I'll ask, so let's see. How are people feeling about working with servos? All right. And if there are any general questions, fire them away. If they're roughly servo related, I suppose, or like library related, anything like that, I'm happy to answer. And if there are no questions, we'll introduce our new construct. Okay, excellent. All right, well, if you have questions, definitely continue to write them down. In the meantime, then, I will get started on introducing this new concept, which in this case is a for loop. So if you did the Python bit, or if you've done Python before, you'll know for from Python. Tragically, for in C++ is entirely different. It's also a loop, but that's about the only thing they have in common. So sorry to break that bit to you, I suppose. But we'll be able to take a look at how we can use those to gradually move our servo back and forth. And that should be pretty all right. Yes, wonderful. And yeah, there's a couple of ways we can do that. We'll go with the slightly snazzier way. Okay. So one thing that we'll want to do then, if we're going to be slowly telling the servo to go back and forth, the way we're going to do that is by telling it first to go to 1 degree, then wait, then go to 2 degrees, then wait, then go to 3 degrees, then wait, then 4 degrees, then wait, that kind of thing. So we'll need to keep track of whatever angle we're telling it to go to. So in this case, we'll make that a number, so we'll call that our target. And we'll start that target out at 0 degrees, I think. We'll start it at 90, why not? and then we can give it a direction to go. So this direction is going to be the step that it's changing this angle by. So this is actually a bit like the speed as well. So actually, yeah, we'll call it the speed. So we'll say the speed. This is how many degrees per whatever time unit we end up using. So we'll start with just +1. So it'll go forward 1 degree at a time. Now to introduce the new construct, which is a for loop. So for loops have, well, I guess 4 main parts. How convenient. So they've got 3 parts in here, which we'll come to in just a second. And then they've got the body. So the body is what you would expect for a loop. Whatever code is in here gets run as long as the loop is running. Now, these 3 bits here in these parentheses, separated by semicolons, are the new bit. So the first place allows you to set some sort of local variable. And let's see, there's a number of, there's actually, I'm going to do this in a slightly different way than we've started, and I think that'll be fine. No, okay, yeah, that's all right. So what this first bit is for creating or setting some variable. This runs once at the beginning of the loop. So if, say, we wanted to create a new position variable, so we could have, and we'll call, sorry, it's an integer, and it'll be the position. The position will start equal to 0. And that's a valid thing to put in that first spot there. Yeah, and that will be fine. Yeah, and we can get rid of this too then. So yeah, so we'll actually, so that was for a different approach. We'll come back to that in a minute. So here with our for loop, we'll start, say, at position 0. And then from there, this middle one tells you how long the loop continues to loop. So here's your condition. These conditions look exactly like something that you would put in an if statement. If whatever is in here is true, it will loop again. Otherwise, it will stop. So what we'll do in here is we'll say, well, is our position less than 180? Because that's the maximum. So our position is less than 180. Then we want to update the value of position, and that's what this last field is for. This gets run at the end of every loop, and this changes, usually, this variable that you've created here in the beginning. So if we want to add 1 to it, we could do a couple of things. You could do position equals the current position plus 1, but that's pretty long, so there's a shorter way to do that. Just like in Python, you can do position plus equals 1. But C++ gives you an extra little trick that you can use. If you're ever making a variable 1 bigger or 1 smaller, you can just use a double plus sign next to it. So what this will do is just update the value of plus, make it, or sorry, of position, making it 1 greater every single time. To demonstrate how this works, before I connect the servos to it actually, I think I'll show you with the serial console. So we can set up that. So we'll do serial again, 9600. Get rid of the random asterisk. And then in here, we can print serial, print line, and we'll print the position, I guess. That's fine. And we'll temporarily get rid of all of this. And then set a delay, I guess, in our loop of a pretty short amount of time, I guess. We'll do 1/10 of a second. So, and we'll do a bit longer than that. We'll do half a second. So if I run this, boop, 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 not going to do anything with the servo just yet. But what it does is you can see it's counting up here. Every half second, it's increasing the position by 1. So what it's doing is first time it goes through this, it'll set position to 0. It's going to do this as long as it's less than 180. So all of these numbers so far have been less than that, so that's why it keeps going. And after each one, it adds 1. So you can see that 42 goes to 43. It's adding 1 value each time. And it's just rerunning this code here in this loop over and over and over again. So we can also see, I'll speed it up so that we don't have to sit here for the whole thing. So if I speed it up and we say this, And clear that, go again. Then it prints out much faster this time, and once it gets to 180, what happens is it leaves this loop, and then it goes and hits the end of this, and then it starts back at the beginning of the for loop again. So once it hits 180, it just restarts its count every time. So that is how that works. What we probably want to do is, if we've slowly made it go one direction, we probably want to slowly go back the other direction. So what we can do is just toss in a second for loop down here. Oops, of course we have to stop the simulation. My bad. Toss in a second for loop. You can reuse the variables because this variable only exists inside of this loop. So you can reuse it elsewhere and it doesn't clash. So we'll also, but here, we'll have our position starting at 180 because that's where we've just stopped if we finished this loop. And we want to continue as long as the position is more than 0, which is our minimum value. To subtract 1 at a time, you do the same thing except with minuses. You do minus, minus. And that will go back down. And I'll try and see what's a reasonable speed to print these at. We'll try this. So if I clear that, go on. What it will do here is first it will count up, and this will take a second. But once that hits 180, you'll see it won't go straight back to 0, but instead it'll move to the second for loop and it'll count back down. So should have picked a smaller number. Then we're going to hit 180 here. We hit 180, and then we're going back down smoothly, you see. Because now we've moved to this second loop here. We're no longer in the first one. And once we hit the end of this second loop, then we go back to the whole loop function, and we'll start back at 0, and we'll count up again. So this current looping system that we have here, once it'll hit 0, it goes back up, and it'll count up to 180. So that is our smooth angle that we want to set things to, because you can see it's moving at a nice slow pace. So it'd be nice if we could just get our servo to go to these positions. To do that, luckily, it is very, very easy. Does anyone have any idea which bit of our code here we should replace with a different line to move the servo instead of printing to the screen? Or we could print to the screen and move the servo. Both are fine. What do people think? We could add a line or change a line. And this is actually moving the servo now is what we want to do inside of our for loops. Any ideas? All right, if not, that's okay. So what we want to do here, since we're already calculating this position, yes, hey. Oh, Philip voice swooping in right after. Yes, I totally agree. So Philip says we should replace serial with myservo.write. So I would agree with that. So for the sake of just having it to look at, I think I'll make that a second line instead of replacing it, but both would work. So I'll do myservo and .write. So that's telling our servo to go to a particular position. What position should it go to? It should go to pause, which is our position variable that we're increasing in this loop and decreasing in this one. We can use that exact same line down here. Wonderful. And then we can get rid of that. And if we run this, now we should see, look at that. Our servo is moving nice and slowly, and we can see that it is matching its angle to whatever numbers are printing out here. So once we hit 90, it'll be at about 90. So there's our 90 degrees, and it'll keep on going all the way up until it's 180. And then it should flip back around and go the other direction, which we'll see now-ish. There we are, and it swapped direction, and now it's sweeping back the other way. So that is how both for loops and servos work. I'll show you a simpler way to write this program in just a second, which is what I was accidentally trying to do the first time, and then I realized it didn't actually involve any for loops. Before I do that, though, are there any questions about for loops? Because those are a nice, new, confusing bit of programming language syntax. So I'll ask in a poll, how are people feeling about for loops in servos? Well, I've already asked about servos, so we'll ask about for loops in particular. All right. See how we are doing about those. All right. 3 people at least, 4 people in first one. Okay. All right. Well, if there are any questions, do definitely ask them. For loops will come up a couple more times, so we'll get to see those as we move through some things. But I think if there are no particular questions about for loops or servos now, we'll continue on to our last little key bit about working with this pin pad, and that's that whole grid style circuit thing. After I do what I promised I said I would do and show you the simpler way to write this program, so I'll go through this a little quickly because it's not necessarily for loop related. But since this is already a loop, you could just kind of merge these into one loop, because if you're looking at them, well, the content of these loops is actually entirely identical. So that's really repetitive. Like I said in the programming with Python session, programmers in general don't care for repetitive things. It's just wasted effort. So what we can do is smush all of this down into one thing, but we need to switch the direction that the position moves, and that's the kind of tricky bit. So for now, we'll just put this whole thing in our loop. That'll only run, well, the position no longer exists. We'll have to recreate position. I called it target up here, I think, the first time, so we'll call it target again. We'll call it position. We'll start at 0. So there we are at 0. And then we will have our speed, which we had before. And that's how much it's changing by. This was 90 the first time. Might as well keep it as 90. So what we can do here then is after this servo is written to and we write out our position we're going to, and we wait a second, we will update our position with our speed. So this is the same as saying that position is equal to position plus speed. So that's incremented it according to whatever this value is. And actually, probably slightly before that, what we want to do is check if we've hit our maximum or minimum boundary. And what we can do is check our position, see if it's greater than or less than 180. So we can say if the position is greater than, or sorry, yeah, we'll do greater than or equal to 180. Then we've gone either the maximum distance or too far. So what we want to do is reverse our speed. Why has that gotten funky with indentation? No, that's fine. It's a bit rude, but fine. Okay, there we are. So if that's got flipped around, then we will want to invert our speed. So to switch the sign of our speed, so if we're adding this, if we want to go the other way, we just want to subtract it. But subtraction is the same as adding a negative number. So you can do speed times equals -1, and that will flip it to being a negative number. But if it's a negative number, multiplying by -1 a second time turns it back into a positive number. So that kind of flips it back and forth. So you could do that. And because this flips it both ways, we can actually also fix the case when we've gone too low. So we can say or, which is this 2 vertical lines. That's the same as Python's or that way. So if we've gone too far in the other direction, which would mean the position is less than or equal to 0, then we'll be flipping the speed all the same. I think that works. Let's find out. Yes, right. So I went to 90 first, which is what I told it to do. Now it's going slowly up to the 180, and then hopefully it'll swap direction. We can look at the serial monitor. Yep, and there it goes, swapping direction. So that was the other way I was accidentally trying to write it the first time. You can see it's shorter, it's less repetitive, so generally this is probably a better approach, but I wanted to introduce for loops to you because we'll be using those later on. Are there any questions about this version? So I'll ask that. This version of servo sweep. I know I went through that one a little bit quickly, so if there are any questions, that's totally understandable. All right. Well, we've got at least a couple of people who said that it's all right. 3 people, which is not too bad. Okay. Cool. Cool. If there are questions, definitely drop them in one of the chats. Additionally, as a pro tip, if you want me to be able to see that you're typing, if you type in the Discord one, it tells me who's typing, so I can see. But I can read on both chats, so that's fine. Lovely. Great. So that's all we'll do with servos for the immediate moment. We'll come back to them soon. Now, we're going to take a look at some grid circuits. So eventually, we want to deal with a grid of buttons. But before we deal with a grid of buttons, we should probably deal with a grid of more simple things to understand, I guess. So we'll have LEDs, which is what I prepared here, because this took ages to build, because Tinkercad's not very good at like building grid things. Excellent. So what this here is showing off is a way that we can, with only 1, 2, 3, 4, 5, 6, 7, 8 inputs or control things, actually turn on and off individually 1, 2, well, okay, I won't count them all, 16 LEDs. So instead of using 16 pins on an Arduino or something to turn on LEDs individually, what you can do is put them in a grid, and then all you need is 8 pins on an Arduino to set them all individually. So what we're looking at here isn't actually an Arduino. I've kept it a bit simple. What these are little switches that can turn on and off or make connections to these individual columns down here, and this one to individual rows. This one's, of course, connected to all positive power, and all these green ones are connected to the positive legs of the LEDs, and all the negative ones are connected to the orange wires. And it's all through this shared resistor, just so we don't break any LEDs. So remember that an LED needs to, well, if you want to light it up, you need to have both a negative voltage here and a positive voltage here. So they need to be both connected. You can't have one side unconnected, because current needs to flow through it. So we'll need to, that's how we can get this to work, is by finding the intersection of where these different rows and columns are turned on. So just to check if anyone's feeling particularly keen, say I wanted to turn on this LED here. Which switches on these things should I flip to turn on this particular LED? Any ideas? And this is the LED, I guess, in the second column, the second row. Any ideas which switches I should flip for that? 2 and 2 is Philip's suggested, so I think that's a good suggestion. So if we flip on, whoops, need to start the simulation first. So if we start the simulation, then we flip on 2, and then we flip on 2. You can see, hey, it's exactly the LED we wanted to light up, and it's just that LED that's lighting up. So now you may be wondering, how is that actually working? The way that is working is when you turn on this switch here, what it's doing is connecting all 4 of these LEDs to positive power. So it's connecting them to the plus side of the battery or whatever. It's connecting their anode. But remember, for an LED to actually light up, it needs to have a full path through there. So you also need to set the other pin to be negative. But at the moment, for pins 1 and 3 and 4, those are all unconnected. These switches are off, so these wires here, these orange wires, are just connected to absolutely nothing. Only this one, when we connect this wire, this whole row actually, to negative, does this current have a path. So it comes in through here. It's blocked at 1, 3, and 4, so it has to go through 2, so it hits all 4 of these LEDs. It can't go anywhere from here, because this orange is blocked. Can't go anywhere from here, because this orange is blocked. And from here, it's the same situation. This orange is blocked down here, so it can't go that way. But this way, it hits this orange wire, and this orange wire is connected, because we flip that switch, and it can go back into the battery. And that's our circuit path that it takes, is that way. So we can light up a whole bunch of different things like this. So we can pick, say, our column 4, row 1. So there's that one. And this, you can do whatever combinations you want. If you want to light up multiple things in a row, you can turn on a row. So row 2 is on, and I want, say, 4 and 2 in row 2 to be on. So both of those light up. You could light up all of them if you wanted. Obviously, flipping all the switches turns all of them on. So you have all of them on there. and you can get some pretty interesting patterns. The only thing that is a bit of an issue here is if you want to, like, say, have all of these diagonal ones on at the same time, well then naturally, first thing you want to do is set up the first one, right? So you want to turn on 1, 1. That lights up our first LED. Then you want to light up 2, 2. So you flip on 2 and 2. But then you realize you've not lit up just, you know, one LED here. You've lit up also these other ones. So if you want to light up, say, a diagonal, we'll need to do something more clever, which we'll be able to see with the Arduino. But this is a good example of how this button matrixing works. So we have 8 inputs, but 16 things we can control with them. Does that make sense to everyone how this LED circuit works? Does that make, or are there any questions that people have? So, LED circuit, the grid one. And we'll apply this idea in reverse very soon. So it is a decently important one to understand. So if you have questions, definitely ask them. Or if there's just something that's confused, if you can't think of a particular question, you can just ask me. If you'd like me to, I can explain a certain part of it again. So let's see, I'm not sure how many people we have in the actual meeting. We have, apparently quite some number of people, but not quite everyone has gotten to the Discord polling. For the people who haven't responded to the Discord poll, are there questions that you have outstanding, or have you just not found the Discord poll? And you can let me know in the Google chat. Is there anyone here who actually isn't in the Discord? Well, okay, I posted the link in the Discord, so I assume you're all there. But that's where these polls have been. Excellent. Okay. Cool. So I'll assume that's all right, since nobody has said they aren't feeling well about it, or, you know, they've all been thumbs up so far. So we'll move on to controlling this with an Arduino, and that'll give us some fancy extra things to do. So to do that, I think, how should I go about this? I will, because I already have a, I've created a sneaky example earlier, but I don't want to totally just give away the answer. So I think what I'll do is just reuse this matrix here and add in an Arduino. Cool, so that's what we'll do. So we'll stop our simulation. We'll go ahead and shop all of these components off the outside. And then what we'll do is drag in an Arduino. And we'll bring it in here. I'll rotate it around. So we have our digital pins on this side. Zoom out a little bit. Excellent. This probably won't be gorgeous, for which I apologize. But we'll connect first the columns up to these lower pin numbers, and we'll do them all in order. So we'll have first 2 connected to the first one. I'll set that to be orange. We'll do 3 onto the next. There. And 4 to the one after that. That is there. And 5 to the one after that. Hello, there we are. Wonderful. All right, so there are all of our columns connected up to Arduino digital pins, so we can use those as outputs, as the equivalent of our switch, kind of. And then we'll do these green ones, connect those to the rows. So there's one row. Here is the next row, the row after, and then all the way up at the first row. Wonderful. Okay. So that is a bit of an ugly circuit, granted, but allows us to do basically what we were doing before, except now with an Arduino instead of just those switches. So probably should have made a copy of all of that, shouldn't I have? That's fine. So what we'll do is we'll go ahead and take a look at our code. Yeah. And now what we want to do is figure out how we actually drive all of these LEDs. So I'm going to introduce a couple of new concepts, I guess, in the programming as well to make things easier and a bit less repetitive. Off the bat, though, what do people think that I need to put in this setup? What are some things that I might need to put here? Any ideas? I'll have to switch back to the chat on the Google thing. There we are. Any ideas what should go in the setup there? If we're working with digital pins. And all except random access. LED inputs. Okay, so what do you mean by LED inputs? Okay. I think what you may be getting at is that we need to set the mode of the pins, for which I would agree. Yes, that as well, actually. That's a very good point. So that we could put even before the setup. It's, yeah, telling it which pins are which. So I totally agree with that. There are a couple of ways to do that. So if we have like our int, and then we'll start with, well, our first row pin is 2, because that's the one connected down here. Whoops, that needs an equal sign and a semicolon. But I think I'll try something a bit sneaky. So instead of just giving it 8 variables here, which is certainly something we could do, I think what I'll do is I'll say where that starts, and since they all go in order, I'll just say how many there are in total. So row pins start at pin 2, and how many rows are there in total? There are 4 rows. And I'll do the exact same thing, but for our columns. So we'll do the column pins. The first column, first column if we're counting from the bottom, starts at 8. So we'll do 8. And then there are also 4 columns. Oopsie. There we are. So I agree, that's definitely excellent to have set up. So now that we have that set up, now I think in our setup, the setup function, that's a lot of setups. Here, we'll want to actually set the mode of all of these pins. Now, to actually set all these individual ones, with this current system we have, we could use something like a loop. So instead of writing out over and over and over again, which lines, or I guess rather which pins we'd like to set to which modes, we can simplify things down a little bit. So we can do that by putting them in a loop. So we can say for pin, and we'll start our pin at whatever the starting pin for, say, rows is. So we'll want to set all rows first. So we'll start that pin at the value of a row pin. And then we'll want to go as long as we haven't gone too far, and we can check if we've gone too far by taking, well, is the current pin less than the place where we started plus how far we have to go, which in this case would be rows. And then if not, then we can just move forward 1 row at a time. So we can do pin plus plus. And that's our little for loop that will go through and give us a pin number for every row. So just to demonstrate what that looks like in terms of the number counting, to make it a bit more visual, we can do this. I'll need to set it up for serial print ln pin. There we are. And if we go ahead and run that, is that going to crash or anything? I don't think so. Definitely does. Boop, 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 boop. Cool. That's not what I was expecting, was it? Pin was not declared, but I have declared it here, my friend. Definitely did not declare it there. That's because that is not even remotely the correct line. It is begin, and then 9600. My bad. All right. It's interesting that it had an error down there. Right. So here on our serial monitor, you see when it very first turns on, it'll print out 4 numbers for us. It prints out first 2, then 3, then 4, then 5, which if you'll notice are all of the pins that our columns are connected to. So actually, whoops, I flipped rows and columns here. I'll have to fix that in a second. But you see you get 2, 3, 4, and 5. So our for loop generates all those for us nice and automatically. I will change the way that these are numbered because they are numbered differently. Whoops, stimulation has to stop. So rows are actually the ones that start at 8 because rows are horizontal, and then columns are the ones that start down at 2. Wonderful. If we rerun that, we'll just get the exact same thing, but counting from 8. I should clear that so it's more clear. Doop. So there you are. Start at 8, 9, 10, 11. So those are the 4 pins for the rows. So now in here, instead of just printing them out, what we could do is actually set their mode. We're going to want all these pins to be output pins. So we'll do, simulation. We'll do pin mode, and then we'll give it the pin that we calculated in the loop, and then we'll set it to be in output. Excellent. So that'll go through and do that for all of our rows. Now, if we want to do the same thing for columns, we can take this, and we can go down here, and we copy it, and it's the exact same thing, except you have to change these all to call, and call, and calls. But you might notice, that seems, to me, suspiciously repetitive. To which I would answer yes. It is suspiciously repetitive, and there is a way we can avoid it. So back in Python, we dealt with this problem of repetitive chunks of code, but with like slightly different values inside of them by building functions. And it's the exact same thing in C++. Functions look quite different, but it's the exact same idea. So what we'll do maybe is create a new pin mode function that can set the mode of several pins at once in like a range, just like this. So to define a new function, we'll go ahead and put it up here. You first tell C++ or Arduino what you want it to return. In this case, it doesn't need to return anything, so it'll just be void. That means don't return anything. Then you can give the name of the function. I'll call it pin mode range, because we're setting it in a range. Then you give it all the arguments. So these arguments look a little bit like these variables here, except you just don't have the other side of the equals. So you can create an argument that is the start pin, and you have to tell it what type. So it's an integer. That's the start pin. So that's where you're starting your counting. So that would be either row pin or call pin. And then you have how many pins you have. So we have the int num pins. And then finally, you have what mode you want it to be in. So these input and output things, secretly, under the hood, those are just numbers. So you're fine if you type int and then mode, and you give it output. Output counts as an integer. But in case you're ever unsure what type something is, C++ also lets you get away with something very sneaky. So if you don't want to figure out the type yourself, you can just say, figure it out automatically for me. And that's what auto is. So this shifts the burden over to Arduino, and Arduino will try, to the best of its ability, figure out what type that mode should be. Excellent. So then, just like these setup and loop functions, you open it up with these curly braces, and then inside you just write your code. So here, this is the code that we want to extract out into a function. So we go ahead and put that in, and we just need to change all these row-specific things to be our more generic arguments. So we'll have start pin, and again, oops, well that was very exciting, wasn't it? And then also start pin, and then here we have the number of pins. So now this is a more generic, reusable chunk of code, and we can use it for both rows and columns. So to use it for both rows and columns, we just pop down into our setup, and here we can type pin mode range, and we want to set everything starting at the row pin for however many rows we have to be equal to in output, or to be in output mode. And then instead of having to repeat a big bunch of code, you just recall the exact same function. Oops, that's my bad. Recall the same function, but this time using your call pin and calls. So now we no longer have this line, which was just straight repeated. We don't have most of the for loop, which was repeated. We only have the bits that changed between the loops, which is, are you doing rows or columns? And then whatever mode you want it. Oh, actually, that's a good point. This should be set to mode instead of just output. Otherwise, it'll always set things to be outputs. So that would be a good example. If I put serial in here, I wonder if that'll work. So if I put serial print in here, you might be able to see all the things that it's doing. So we can say just print the pin, and we'll go ahead and run that. Oh, I should have cleared that first. Oops. It's my bad as well because I didn't put print line. Print line, but it cleared. Go ahead and run that. There you are. So you see it runs twice. It first runs for the rows, which is 8 through 11, and it also runs again for our columns, which are 2 through 5, which is done there. And that's nice and clean. Does anyone have any questions about how functions work? They're nothing too wildly different from what the setup and loop already look like, but defining your own with arguments is sometimes a bit different. So are there any questions about functions? So we'll ask that. All right, a couple of people feeling okay about functions. That's good. Does everybody understand why we would use functions and why they're useful? Here it might not be the most like convincing example because there were only 2 places where we were using it. But if you were very, very often using for loops to set a whole range of pins to some mode, then this would be very helpful because you don't need to write that everywhere. Okay. If people have questions, definitely drop them in somewhere. The number of responses on the Discord poll has been slowly waning, but that's all right. There haven't been any negative, nobody feeling poorly about functions that they've said so far. If you do, feel free to say so, and I will go over them again. But okay, we seem passably all right at the moment, so let's power onwards then. If all of our pins have been set up, do we want to try maybe one of our examples, I guess? So if we wanted to light up this pin here, or, well, let's just light up the first one. So if we light up the first row, first column, and we're counting our rows from the bottom because of just the way I've numbered things, in which case you have this one will be our first row, first column LED, the bottom left. So if we want to light that one up, does anyone have any ideas how we would do that? Any ideas for lighting up our bottom left LED in terms of things that we should write in the loop, or we could write it in the setup. Both would be fine. Any function that I should use? Okay. So, there we are. Always. There we go. The delay. Perfectly timed, Philip. All right. So Philip said digital write. I would agree. So here we can use our digital write. And with our digital write, we can go on and create, or we can tell one of our pins to go to a higher voltage or a lower voltage. So in this case, what we want to do is turn on the row. Yes, so the rows are the positive side. So we want to turn on our row 1. So we can do that by saying digital write row pin, because that's the first row pin, remember, to high. Don't know how that happened. Oh, I pressed caps lock. To high. And then we want our other one to be set to a low voltage so that it can go down and the current can go through it. So we'll take our other one, we'll do digital write call pin, which is the first column, to be low. And now we'll run this, and we're going to run into a bit of a problem. I won't yet ask what the problem is because it involves lots of like implicit behavior, but we can take a look at it. So if we go ahead and run it, we can see, that's a bit curious. This entire row of LEDs has turned on. Now, the reason for that is that by default, when you create something and you set it to output, its state gets set to low. So all of these LEDs, except for row pin 1, which we just turned to high, are set to low, which means that the power can come out of this first row and it can go back through any of the orange lines because all of those are set to low. So what we need to do to fix this is in our setup, we want to set all of our things that should be low when they're turned on to their turned off state, which is high. So if we take all of our, in this case, it's going to be our things connected to the negative end, which are our columns. So if we loop through all of our columns and turn those to be high, then you'll see that we don't get anything. So if we do, say, this call pin, we set this to high, actually, so that'll be a good example. So set this one to high. Now it's high on both sides, so there's no current that flows through the LED because it's the same on both sides. And you'll see that we get the first one turned off, but then the rest stay on because they've got the low on the other place. So we know that by setting a pin on its column to be high, we can turn it off by default. So now all we need to do is just do that with a for loop, say. So in our setup, if I wanted to set, or if I wanted to do a digital write to every single column pin, how would I do that here with a for loop? Any ideas? Well, I'll start with a for structure for you, and I'll ask for one part at a time. So what is going to be the first part, which is this bit? So what here? And I'll write the rest of the for loop in while I'm at it. Any ideas? I'll eventually be putting a digital write inside. All right, if there are no ideas right off the bat, then I might just go on and help out with this bit so that we have time to still get to some other things. So the first bit of a for loop, recall, is where you're setting or creating some new variable. It's where something happens once at the beginning of the loop. So in our case, maybe it'd be helpful again to create a pin thing. So if we want to keep track of a pin, we can do the same as what we did before with our pin equal to, and we want to start at the column pins. So we do call pin, just like that. So we're starting with the columns because remember the columns are the ones we want to set to high. And we want to do that for all of the columns. So we want to do that for as long as the pin is less than the call pin plus the call. So this is exactly what we had going on here. In fact, I personally find what we're going to write here, despite the fact it's a digital write instead of a pin mode, still like a little bit repetitive. So there are other ways that you could write these functions to reduce that duplication, but I think it's passable for now. So, and then what you do is just the same as before. So it's just exactly how this up here works before we changed it to be in this function. So this goes for every column, and for every column what it will do is go ahead and write to that particular pin, which we can get from the pin variable, to be high. So now, if we go ahead and do what we thought would work before. So we thought that would work correctly, but it didn't. If we go ahead and try this, now we'll get our expected result. So additionally, you'll notice Tinkercad is complaining because this LED is being driven with too much power, and it is. So in the real world, please put resistors on all of your LEDs. The only reason I did not in this case is because it would have been a lot of resistors to add. So that's why there aren't resistors here. It's a simulation, so luckily these things won't actually explode. But do keep that in mind in the real world when you're actually dealing with LEDs that you don't want to blow up. Wonderful. So now this works as we expect it to because all of these rows are set to a high state, which is the opposite of what they need to be. Because all the columns are set to a high state, which is the opposite of what they need to be because they need to be low because they're connected to the negative side of the LED. So that's why all of these have turned off by default, and only this one turns back on once we turn it back to low. And you see if we get rid of this low statement here, oops, so if we get rid of that second statement, then it doesn't work. Nothing turns on, they all stay off, which is what we expect. Because essentially what this is doing is setting this row to be all high on one side, and it's also all high on the other side. So there's no real difference, so there's no flow of electricity. Excellent. Cool. Now we're ended up with a lot more familiar looking for loops. So I think it would be cool to go through and light up every one of these LEDs separately in an order. And just to show how you would do that in a clean way, you can use nested loops So a for loop inside of a for loop. So I'll show off what that looks like. All right, so inside of this loop, we have do people like rows or columns more? Which should we loop through first? What are people feeling? Give me a row, give me a column. What's your favorite direction? The vertical, the horizontal? Any preferences? The crowd goes silent. Nobody knows if they have a favorite direction. Column. I like you. You're dedicated. You know what you like in life. You like columns. We'll go columns first. Wonderful. So we'll start with a column. I'll abbreviate this to just be C, since we'll be using this variable a lot, so keep it nice and short. We'll start at the first column, which is all just something we've seen before. Start at the first column. We're going to go through all of the columns. So this is exactly the same as we've seen probably too many times now. Yeah, I think it would be good eventually to write a function that definitely gets rid of all this repetition. But regardless, good practice, I suppose. So this goes through all of the columns, and it's adding up each time. All right, so that is our first loop. And now what we want to do is inside of the column loop, we want to loop through the rows. And I'll talk about what this practically does in just a minute. So row, you can ponder it in the meantime. I have to change all these bits. Row, row, row. Your boat gently down the stream. Excellent. All right, so actually, I can show you what this does. So if I do serial print, and print does it without a line, so we'll print it in columns, then rows. Yeah, that's fine. So an opening bracket, and then we'll have another line. Arduino's managed to like handicap printing, so it makes it a lot more, well, like normally in C you can do some more clever things than what I'm doing here, but it makes it a bit more difficult in Arduino, so we'll do it the way that they want us to, which is just a series of prints. So all these are going to go on the same line, because I've not created a new line yet. So we'll have a comma there, then we'll print our row, which is an R, and then we'll close our little bits of brackets there with this. All right, and this last one that we're closing with, we make a new line. So if I go ahead and run that, oh yeah, that's gonna be a mess, but that is fine. That's gonna be a lot of fast moving mess, so I'll put a delay in there. 10 seconds. Okay, so if I go ahead and start this, and we look at our serial monitor, we can see what we get is that, well, whoops, it went there, so I'll clear that. It'll go in just a second. Oh, actually, no, that was totally fine, and I was just being silly about it. Yeah, there we are. Okay, so this is entirely fine, because what we're doing here is it's first giving us our column pin, so we're starting at the pin 2, and we're pairing that with the horizontal 8. So I'll go ahead and stop the simulation, actually. Then it'll stop rerunning. So the first thing we do is 2 and 8, which is this one here. And then if we want to access the next LED, it'll give us this new combination. It gives us a 2 and a 9. So that's one more up this way. The reason this works is because, well, this runs over and over again, because that's a loop in general. This runs once for every single column, but for every column, you run something again for every row. So inside of here, C doesn't change. So C is the same this whole time, which is why you get C is equal to 2, then it's 2, then it's 2, then it's 2 again. Because you get 4 of them, it's 2 the whole time, before it changes up to the next one. But you can see that the row changes each time. So basically, putting loops inside of each other like this allows us to access every individual point of the LED matrix, I guess. Then what we can do inside of each of those points is something, instead of printing it, we can actually, well, let's keep the printy bit, because that took ages to write, and we'll also turn on the light there. So this turns on a light at a particular position. Whoops. So, all right, and our row, we want to be the high value, because that's the positive one. So we'll set our row to high, our column to low, and we'll wait for a second. And then we need to make sure to clean up afterwards. So we'll just reverse those states afterwards. So here, we'll swap them just so that the row is going to be low again, and the column is back to high, which is the off position. Now if we run this code, and I'll make that delay a bit less horrendous, we'll do 2 seconds. If we go ahead and run this, what we can see, first we light up to 8, then we light up to 9, then we light up to 10, then we light up to 11. Then we move in the outside loop to the next column. Then on the next column, we light up the first, second, and third, and fourth rows, and then you go on and you do it again. And you go over and over and over again like that. So what you can do is you can make this really fast. So if I do make this really fast for you, so let's see if I go down to as small as we can get with our little delay there. It does take a second to turn on though, doesn't it? So maybe we'll do 5 milliseconds. Let's see how fast we can get that to fly. And serial sometimes slows things down, so we'll comment that out. Fun trick for C++. You can comment the whole block by doing a slash and then an asterisk, and then when you close it, an asterisk and a slash. And that comments the whole block out. Sometimes helpful, means typing fewer slashes. Excellent. So if we run this at a much increased speed, we might be able to see all of them kind of lighting up at the same time a little bit. Yes. So you see here, there's a bit of a strobing effect, which, fun fact, if you ever see this weird like wavy effect on a television, for example, or yeah, some other display, that's because they get updated like this, just much faster than this is updating. So you usually can't see it with your naked eye, but what cameras do, you probably usually see this rolling weird thing when you're like watching a movie or some video recording. The reason that happens is because the video recording is just taking really quick pictures every few seconds, and so it only catches one snapshot in time, and it kind of moves along. So if you've like watched on a video, say a rotating wheel, at some point it looks like it's spinning real fast, then maybe it looks like it stops spinning, then it looks like it's going the other way. It's all just an artifact of the way that the camera takes, or the video camera takes repetitive pictures. But anyways, lots of things work in this kind of way where it lights up things one at a time. If we want to make it even faster, we probably could. I think that might be okay if we did that. Yeah, so here we are. It looks just about solid across the whole thing. There's a little bit of a flicker. Obviously, it's dim because we're driving all of them at the same time, and that takes a lot of power. But you see there, it lights up all of them at once. Now, just because we couldn't do it with our earlier setup, but we can do it with this fun trick, we can light up all the diagonals. So there's a property of these, well, of this diagonal actually, and that's that the row number and column number are the same. So what we can do is if the row is equal to the column, then that's when we want to light up our whole thing here. So that's where we'll put our lighting up code. Click, clack. So if we do that, then we should only get the diagonals lit up, theoretically, but we do not. Of course. Sorry, that's my bad. So remember that these rows and columns are actually the pins that they're being lit up on, not the actual row and column itself. To get the actual row and column itself, you just need to subtract the first number, which is the row, not the row call, the row pin and the call pin. That's my bad. Let's go ahead and run that. There we are. Now we get our diagonal lit up, which is something that we could not pull off earlier. And again, the fact that all these are on at the same time isn't breaking the rules of this grid. It's not some sneaky, way to break physics. It's just an illusion, because if you increase the time back to something that you can see again, so we'll do 500, 200. So back to something you can see again. You see what it's doing is really just lighting them up in sequence. But it's just doing it very, very quickly. So it's flashing them all so quickly, they look like they're just stuck on constantly. And that's the little trick that it can play with you. That's a trick that lots of computer displays play with your persistence of vision. So there you are. There's the diagonal. All right. Are there any questions about that? That was a lot. So I'll ask, how are people feeling? are people feeling about, I don't know, nested for loops, I guess is kind of what this is. Nested for loops. All right, any questions on how this works? All right, people seem feeling all right thus far. That's good. That is certainly good. What does the logic say in the last if statement? That's a very good point. Yes, so to show off what it shows off, I will uncomment some things for you. So, yeah, and we'll run it just slower, and that's fine. So, a bit slower than that, 500. And we'll uncomment our printy bit. So if we run this, we can see, well, that's a bit, right, of course, because it's only delaying on those ones, which makes sense. That's fine. We can fix that. We'll just put it inside. Yeah, that's okay. What this last line is saying, the if statement, is it's basically asking, oopsie, that's the wrong button. Are the row and the column the same? But you'll see that there's a little bit of a caveat there, because the row and the column are actually these pin numbers currently. It's the row or column pin and the row pin. So that's like 8 through 11 and then 2 through 5, which are obviously never the same. So when we run this, we can see that, hopefully. Yeah, so you see, so these are going through. And even though this is along a diagonal, so this is row 1, column 1. This is row 2, column 2, row 3, column 3. They should all be the same. They're obviously not because they're different pins. All we're doing here is subtracting the starting pin of either one to get those relative row numbers. So if we subtract from here, I cannot do that while the simulations are running. Subtract from that the column pin, and subtract from this one the row pin. You'll be able to see what that gives us is the relative, the actual, well, I guess the real row and column, right? So you start the real 0, 0, then you move to your 1, 1, then you move to your 2, 2, then you move to your 3, 3. So by doing this subtraction first, we just can check if this first number is equal to the second number. And if it is equal to the second number, we know it's on the diagonal, so we want to light it up. Does that make a little bit more sense? Does that answer your question, Philip? Excellent, fantastic. Yes, that's a very, very good question. Because it's obviously something I forgot as well, because the first thing I tried was just, is R equal to C, which of course it never is, because they're totally different pins. Wonderful. All right, so that is our little grid for LEDs there, which is kind of cool. Well, let's see if there's a history available there, but that's fine, so we'll stop that simulation. Now, it's on to our final project, which is our pin pad thing. I don't think we'll quite have time to go through the whole thing in full, but I think what we definitely can do is get a good start on it, answer some questions, and then I can assign it to people as like a problem to do on your own time kind of thing. And I'll be sure to include, like, I'll share the schematic with you so you can use it. So I'll first duplicate it. Should have done that before I wrecked that last project. Whoops. So we'll create a new one, and I'll very quickly jump into the code and destroy it all. So we have to start from scratch. All right. So here is our hardware. I'll real quickly explain this hardware so people can understand that. We have our servo connected here. This is just the normal way that we see a servo connected. It has power, ground, and then this PWM pin 6 that's connected to the signal bit. So servo is totally ordinary. And you might recognize what we're doing here. It looks like it's a 4x4 grid. And, just like the LEDs, this is a 4x4 button grid. Dealing with buttons here is actually a little bit different than our lighting up of LEDs is. Maybe slightly simpler even, which we'll get to see. So, the way this is hooked up is these first 4 are the rows. so we can't actually see the wires ourselves anymore, but these first 4 are the rows, these second 4 are the columns. And this time they're numbered, this is row 1, row 2, row 3, row 4, column 1, column 2, column 3, column 4. So it's starting from the top left now instead of the bottom left. So let's then start with our the things that we know we'll need. So we know that we'll need our pin assignments. So I forgot. If you're setting pins, it's usually good practice to use const. Not that I've been doing that. It doesn't technically change things, but it is good because this ensures that you don't accidentally change these pin variables while you're actually running your code, because if you do, that could break things and have unintended consequences. So you'd have your constant for your row pin, which is something very similar to what we've seen before. This is 2, so this time it is actually the row pin that's 2, because this first row 1 is connected down to this wire, which is indeed connected to 2. So that's where we start there. In our keypad, I'm not using these 4 buttons, so I'm only using this section of the grid. So what I can do here then is, I'll do the call pins as well. So the column pin, that'll start at 8. And then we have our row count. So our rows is 4, because we are using all 4 rows, all of these, because I'm using this section here. So that's 1, 2, 3, 4 rows. But I'm only using 3 columns. So even though our code and hardware could support all 4 of them on the touchpad, at the moment, well, it doesn't really matter actually. So we'll start it with columns. So you could set this to 3, which is what I have it in the final project. You could also set it to 4, and that's fine for our testing that we'll be doing. We'll just try and, I think, get these buttons reading. Excellent. I will copy an old friend of ours that we've seen before over from my sneaky second monitor. There's our pin mode range. That's exactly what we saw earlier. We're going to be using that again. It's kind of useful to have. And then what we're going to want to do is we want to create a setup. So in our setup, which I deleted accidentally, whoops. So in our setup, we want to set our pin modes, but we need to think about what those will actually be this time around. So when I press a button, what that's doing is connecting a circuit. And that's connecting a circuit, in this case, from a row to a column, or vice versa. It can be it's bidirectional, obviously. So what we need to do is decide, instead of setting one of these, instead of setting rows to be high power, and then columns to be low power to get electricity running through an LED, what we can do instead is set one of these things to be an input so that we can read it as we go along, and then on the other set of them, so say I'll set columns, for example, to be an input, so it'll read each of these columns, and it will read wherever it can pick up the output voltage that we'll be putting through the rows. So normally, when I put an output through the row, it doesn't show up on any of the columns because none of the buttons are pressed. But if I pressed 9, for example, that connects row 3, column 3. So when I put power through row 1 and I check all of these columns, no power comes back. Put power through row 2, check all the columns, nothing comes back. Put power through this row, and check all the columns. This I get nothing for, nothing for, nothing for, but then here in the middle, since these are connected, the power, the 5 volts here, comes back, and it can be read on the column, because it's connected now because I've pressed the button 9. So that's how we can read which button has been pressed, if that makes sense. We'll be able to see that in the real world in just a second. So to do that, we'll do a couple things. First, we'll set up our serial, because we'll need that anyways. So serial begin, and then our default baud rate. Then we want to set a range of pins. So we'll do pin mode range, which is our nice function we brought over with us. We'll start with the rows first. So we'll say from the first row pin for however many rows we have. I want those to be outputs, because we're going to put power across the rows. So we'll do that. Then we have a similar looking but different line, this time for our columns. But this is different from what we did before. So call pin calls, but this is now no longer an output, but instead what this is going to be is a resistor, or sorry, an input that has connected through a pull-up resistor. So we have an input here, but remember when we were dealing with button presses, we needed to use input pull-up, otherwise we'd get some janky results. So to do that, we'll just set on pull up. And what that does is when it's connected to nothing, when this pin is floating, because remember when these buttons aren't pressed, it is just connected to nothing, it will pull it up to 5 volts. So actually what we'll be doing, since the Arduino only allows pull-up resistors instead of pull-down ones, is we won't be putting power across the rows, but we'll be putting 0 volts across the rows. But the effect will be essentially the same. Excellent. So because we're going to be putting power, or I guess not power, but low across all the rows. How do I want to do this? Write that low. Yes, right, so these will be pull up. That's fine. I'll just need to set them all to be high beforehand, and that's okay. So what we can do now, I think that'll be all of our setup there. Then we can create our loop. Have our loop here. This is what runs repetitively. And I'm just checking because we need to make sure that we have this done the right way around. Very interesting. Aha, yeah, okay, so there we go. That's how that works. Got it. So if we're wanting to only put power down, or rather put 0 volts across one of these at a time, we need to keep the rest of them high always, because the reading end is going to be high always. So what we'll do then is in our setup, we can run our for loop just like we did before last time. We'll go over rows this time. So I'll do int we'll do pin. We're starting that at our row pin, rows, and we're starting at row pin, and we're going as long as rows is less than the row pin plus however many rows we have. So this is just the same pattern we've seen before a million times. Now we'll do pin plus plus. Right, so that counts through all of our pins there for all of the rows, and we want to set all the rows to what? We want to set them to be high, because our inputs are being pulled up, so we want to set these all up so that by default it doesn't detect anything out of the ordinary if you're, say, pressing a button or whatever. Excellent. Yes, and that makes sense. So we'll do digital right onto this pin high. Wonderful. All right. Then we need to do our nested double loop thing to access one of these at a time again. So it's going to be a similar pattern of what we've seen before. So I'll kind of go through it decently quickly. I'll start with the rows. So in fact, I'm actually just going to, because I'm kind of sick of retyping the exact same line, I'm going to make this line. And this is just going to be our row, and that's just counting up the row. So we're going to go in row major order this time. Sorry, all you column fanboys. My example was written with rows that I put together a couple days ago. And I trust the me of a couple days ago more than the me of right now. So that's what we're rolling with. And this one's just going to be the same, but for columns. So it's going to be your call pin, calls. Definitely lots of doing this. Call pin, calls, and C. All right, excellent. Okay. So now we'll be going through the whole grid again. And when we're going through the grid, we want to do some different things this time. So before, what we were doing is setting the row thing. I think we can get away with setting, sorry, that was very undescriptive, setting the row thing. Before, we were setting we were using digital write on both the row and column pins inside of this inner loop, which meant that we were just repeating it every single time. There's a bit of a nicer way we can do that. That's just, I guess, it's running less code, and that's just by keeping on the row the whole time checking all the columns, then turning off the row at the end. So before we check all the columns, it's just before this for loop. So that means we can put in our digital write here. So we want to do digital write pin for the row. So we want to set the whole row to be low, which is the opposite of its default state, because by default it's high. Remember, that's what we did here. So we're setting it to be low, and then what we can do is go through and we do a digital read. So we'll get let's do state. We'll put it in the if directly. So we'll just do if, and then you can do digital read, and we're reading which pin? We're going to read the column. So when we read the column, this will run whatever code is in here if it's high. But remember, by default, because of these pull-up resistors, if nothing is pressed, it's going to be high. We actually want it to run something if it's at low. So to flip that, we just say if it's not high. So we can do that. And then inside of here, we can run whatever button press code we have. So we'll print currently just to the serial line. Yes, and we're nearly out of time. This will run about perfect, I think, to up this, or run out of this time. So pressed. We'll eventually add some more there, but we won't just yet. So if we do that, then we need to be sure to close all of our if statements and all of our for loops, which miraculously I've done somehow. And then remember, after we're done with all of these columns, we want to turn off that row so that it's reset for the next one. So we'll turn off that row by setting it to its default again, which was high. And that happens after you're done checking all the columns in that loop. Okay, this might work and do what I want it to do. Let's take a look-see. So, all right, serial monitor, nothing yet. If I press a button, theoretically, it should print pressed. And it does not do so. Is that because of my delay, maybe? So I think we need to add a delay, and there might be some other squirrely things going on, so we'll get to the bottom of it. Yeah, and you'll be reading those, which is fine. Yeah, okay. And for each one of these buttons that I'm checking, I'm going to want to put in a bit of a delay, which is fine and expected. I'll make it a really short delay, though. Just up down here. Excellent. All right. And I think that should be all right. Clearly, there's something going a little squirrely, so we'll figure out what that is. Yeah. I'll print instead this digital read, I think, so I can have access to see what that is. So serial print ln and the digital read. All right. Excellent. Let's run that and see what we get on our serial monitor. We should get a bunch of garbage now, but we do not, which is very curious. Which must mean it's not ever looping through there at all. So I must have typoed one of my loops. Does anyone see any of my typo hanging around anywhere? Any mistakes? Because it doesn't even, well, if this is to be trusted, it doesn't seem that we've even made it quite this far. So maybe then we're getting stuck out here somewhere. Let's try just printing something in our very outer loop. This should definitely print. Oh dear, that's not what I wanted to do. Go away, bookmarks. So put something out here. This should definitely print. Hello. Classic print statement debugging. Probably not the best practice, but best you can do with these tools, maybe. Now this is very strange, because I'm not even getting anything from that, which means that our loop is not even running a single time, which is interesting. Which means we're getting stuck somewhere else. Maybe we're getting stuck before that. Anyone stuck? Yeah, stuck in the setup. That's kind of what I'm thinking as well, Philip. So maybe our loop there is getting hitched. So let's check if we run this here. And I apologize, yeah, we've just hit our end time. I'll try and get to the bottom of this, and I'll get to the bottom of this on the recording as well. So if you do have to go now or 2 minutes ago, that's totally fine. This should only take a second to fix, and then I'll just describe the rest of the problem for people who want to give it a go on their own, and I'll post my example solution eventually on the channel for y'all to compare to, as well as a link to this so you can just clone the hardware. Okay, so let's see, we'll start that. Did we get a hello now? Okay, we get a single hello, which I think you're right then, Philip. We're getting stuck here, so let's take a look at that. So as long as, yeah, okay, well there's your issue. We found it very immediately. Can anyone see the issue in this line of code? I've spotted it. Anyone know why we're getting stuck in an infinite loop? And it's a very, very silly mistake of mine. One of those variables is not the variable it should be. Anyone have any idea which one? If the condition part is the part that stops the loop, what's wrong with the condition? Why is it never stopping? Yeah. So as Philip has pointed out, what I really want to do is check if this variable that I'm increasing is less than that value there together. Whoops, stop the simulation again. And if it's less than that simulation, or less than this sum, what I was doing was just checking the rows number, which, as we said earlier, is constant and will never, ever, ever change. So since 4 is less than 4 plus 2, and none of those numbers are ever allowed to change because they're all constants, then it's just going to run infinitely. And never move on, which was my bug. So very well spotted, team. Now we can give this a go and see if we have a bit better luck now that we have gotten rid of our bugs in the system, or at least one of them. Excellent. Okay, there we are. So we see a bunch of things that are pressed. Stellar. Interestingly, we occasionally get a 1 there, which is a bit interesting. Why is... where else are we still printing something? I'm curious as to where that is actually coming from. Yeah, here we are. There we are. It's printing the digital read. That's my bad. So if we stop that and we get rid of that, then we'll just see that hopefully when it's not pressed, that's the only time it'll print the press. Which is also interesting because that means that it seems to be floating, which it should not be because it's been set to a pull up. But we can verify that, so we can go ahead and clear and start the simulation. Right, so that's just printing a bunch of pressed, but it should not be, is what I was thinking, though. Intriguing. Okay, so I've managed to do something silly here, and again, I am not sure what. Because all of these rows, right, should be set to be high until that's set to be low. So this pull-up should be setting this to always the same thing, especially when none of these buttons are being pressed, but that is not the case, is it? Which is quite curious. I'll admit, I'm not entirely sure what the issue in this case is, because I have identical looking code that works for this, unless I'm being very silly somehow. So trying to check if there's anything that I've missed out on. Am I reading the right pin? I'm reading the call pin, which is fine. That's the one that we're wanting to read. We can print that pin that we're reading. But I think that's fine. Interesting. Well, we may have run into some squirrely issues, which might take more time than I would like them to resolve. There we are. We've hit yet another issue. Oh my goodness, it's the exact same issue, in fact. Oof, that's how you can tell I'm too tired. That should be an R. That should be a C. My bad again. Goodness gracious. All right. There we are. That's much more sane. We can get rid of that noisy line. Now we get what we were looking to get. Okay. Very sorry for all of that for loop issues. I guess I'm hungry and tired. Right, so now we get nothing. If I press a button, you get a bunch of presseds. and it doesn't matter which button I press, it will always give me that, as long as it's within my range. My current range is everything, which is fine. But the last thing I'll do, and then I'll set you all free because it's already run over time, is how you can calculate which button has been pressed. So if you think about it, you can calculate which button has been pressed from the row in the column that you've detected it in. So what we'll do inside of this if statement here is first what we want is the real row and column, because remember these are pin numbers, so we do the same thing we did before where we took our the real row is going to be r minus the place where it started, which is this row pin. That's the offset. We'll have column minus is equal to, the C minus the column pin. So that gives us our real row and column. We can print those really quickly. So, do I still have all that other code that printed that? No, I do not. That is fine. So we'll just show the calculation result. So we'll be pressing, and we need to say which button it is. And to do that, we can just print out the calculation. So the calculation looks like for you take the row and you multiply that by the number of rows, and then you add to that the number of columns. Now, why this works, if you think about it, if this is 0, 0, you are here in row 0, column 0. You're going to get 0 multiplied by rows, which is still 0, plus 0, so you'll get the 0th button. If you go one button over, this row, remember, is still 0, so rows doesn't contribute anything at all. So you're just at one column over, so you get 1. So this is button 1, then you get button 2, then button 3. Then, when you wrap around, what happens is you take the number of rows, which in this case is 4 rows. So you take 4 plus, and you're in the 0th column. So that gives you the 4th button, which is this one here. So, because this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and it wraps like that. So that's how that calculation works. If we put a print line at the end of that, then we can see something actually useful. So if we start the simulation here and find out that we've run into an issue, of course, whoops, these are new variables, so you need to give them a type. I'm trying to write in Python, should not be doing so. Alrighty. There we are. Open up our serial monitor. We get nothing. If I press 9, you can see it pressed 26. Well, that's a bit curious, isn't it? Yep. Yeah, of course. Right, so I just told you that I calculated the real row and column, then I didn't use them, so you have to use row and column here instead of R and C. I'm clearly far too tired to be programming, so yeah, we'll call it a close here once I've got this working, which should be now. So here, if I press that, that is our 10th button. Now you might be thinking, okay, that's a 9. Yes, that's true, but remember we're counting 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the 10th button. If we press the first one, we get 0, 1, 2, 3, 4, 5, 6, 7, and so on. All right, I realize it's late. Are there any questions about this? Because I'll leave that here, I think, because we've gone a bit over time. What I will do, though, is I will give you a link in the Discord right after this call, this pinpad thing, with all of the code that we've written so far, and it will be your job to get it so you can enter numbers and move the servo. And I'll describe that in a bit more detail. So we want to go for the example that we showed at the very beginning. So one of the things you'll need to do, for example, at the moment, when I'm pressing like a button, you see it presses it, it activates it a whole bunch of times. So earlier, when we figured out how to only print that thing once, you're going to need to use that code. You'll also need to use the code for driving a servo, and then also a new thing for digits, which is just something you can do mathematically. Okay. Yes, so I will create a quick poll to ask how people are feeling, despite the fact we've gone over a little bit. How are people feeling about this pin pad? And if you have any questions, definitely feel free to ask them now. If you don't have questions, then feel free to get on with your life, because I've already kidnapped you for 11 minutes longer than I need to. And I will be sure to put this code and some further instructions for your challenge, I guess it'll end up being, in the Discord. But yes, if there are any questions, do ask. Otherwise, thank you for coming along. The poll has gone entirely unanswered thus far. Perhaps everyone's just very tired. Me too. We got some mixes. Oh. Interesting. Okay, so we'll see how people are feeling there. If there are any questions or anything that you'd like me to re-explain, I'm happy to stay here and answer those. If you have no questions, then yes. I will see you hopefully for next week when we do 3D modeling, something very, very different. Happy to help, yes, and I'll be sure to send more information in the Discord. Night. See you, Philip. Kate, do you have any lingering questions?
No, I'm alright. I only caught the second hour because I work till 5, but I'm gonna watch it and catch up. I think I followed along. I mean, the coding part is fine.
Cool. Yeah. Yeah, the coding bit's not too bad, except for, geez, when I make a bunch of typos and errors. Yeah, definitely not on my peak at the immediate moment, but that's fine. Cool.
Yeah, no, it's good. All of the BCI people were there, or at least I saw 3 of them. So yeah.
Awesome. Yeah, it was a pretty big turnout, I think. Yeah, which is awesome.
Well, I've told them they have to go to them, basically.
Yeah. Wonderful. Fantastic. All right, cool.
See you tomorrow then.
Yeah, sounds good. All right, see you then. Bye.